Okay, so some questions are easier than others when you are transforming words into equations and vice versa. We'll start easy. There's some time, it really depends on how much practice you've had, but I hope that people will be able to pick it up quickly. There are certain keywords that you might look for, such as increased, such as times, such as divided by, decreased. You will see other words like less than, product down here, if you see it, right? There's a whole bunch of keywords that will help you figure out what your mathematical equation is. And the word problems you see will be the same. 2 times a number and 8.
2x plus 8.
So yeah, so there are some discrepancies, right? Let's put it this way. Mandy's like, okay, let's go from left to right. 2 times a number and 8. And you want to have a different interpretation? What if I said 2 times a number and 8? Well, that's why we need to be very, very careful with our word statement.
Just 8, 2x and 8 is there.
What if it's 2 times a number and 8? So add a number and 8 first, and then you're multiplying that by 2.
How do you know to put it in brackets?
That's exactly it. So
it's not like that.
The goal of being able to interpret the word is super important. So a sentence like this can be confusing. That's sort of the point.
Right? Is there a way it can be described similarly, but it actually means 2x plus 8 instead?
There is a way, you just have to add more words. You have to be clear.
So like if you were to say you were to describe 2x plus 8, how would you describe that?
How about you can say 8 more than 2 times a number.
So that would be 2x plus 8, that wouldn't be in brackets?
Well, read the question, read the wording and see if you can make sense of it. So take this.
Again, it's not times anything.
The 10 is not multiplying with the 3. There's no ambiguity. So something like this, you can say 3 less than.
What if you just did like
10 times
a number less and then subtract and minus? Are those words not going to be in it though? It's more than
you can do that. Here's another one. Okay. 10 times a number subtracted by 3. But if you read that carefully, could there be room for ambiguity? 10 times a number subtracted by 3. Depends on how you read it. Well, how about this? 10 times a number, 3, subtracted by 3. But if you just read it without knowing where the break might be, there could be ambiguity. It could be this or that, and you can argue, and that argument won't disappear.
Yes, they would maybe think that the comma, like there's no break, so then it would be 10 times.
10 times
a
number that was already subtracted by 3. So it's tough. So wording, the whole point of this exercise is that wording is going to be very, 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 very important. So same with this one. A number divided by 5 decreased by 8. How about we fix it then? Let's say I wanted this. A number divided by 5 then decreased by 8. Does that make more sense? Does that clear things up? A number that is divided by 5 and then decreased by 8. So there's no ambiguity. The goal of these questions are essentially to get you to see the importance of reading carefully, because there can be confusion.
Oh, and I also see that like in E, it's like when you're trying to explain in C, it's because that even if there isn't like a discrepancy in number C, there's no way you could explain E differently. So it would also have to be explained the same way. So it's hard.
Yes.
Yeah, so it's like if you're not two things.
So my challenge to you as a class, there are efficient ways to do this. There are not so efficient ways to do this, but either way, your language has to be clear. So I'll give you a minute to think about what the order of this should be and communicate that order correctly in words. So inside that bracket has to be first, and inside that bracket, you have to multiply with the 2, not subtract by 4. How would you do it? As long as the wording is clear, there's going to be more than one answer to this. I will provide a suggestion of my own in like 30 seconds. So see if you can translate that. And if you feel confident, move on to the other ones, because I don't think I'm going to complete all of these. I'll do the ones that might seem a little more tricky. Take a minute. All right, so I could make this as unambiguous as possible by writing lots of words. Okay. A number, a product of 2 and a number, that is, sorry, 2 and a number, or how about 4 less than the product of 2 and a number, multiplied by 3.
3 multiplied by.
Sure, there's a I'm sure the answers will vary. How about product of 3 and a number that was multiplied by 2, then subtracted by 4. As you can, there's a lot of words that you can write, right? But it has to be clear.
The bracket ones are kind of tricky.
Correct. So my recommendation for things like this is to follow BEDMAS. Why not do the bracket first and then do whatever's on the outside later? Okay. So a couple of things we can do. I'm going to clear this and go down. Let's try some other examples that I think could be tricky. The ones that are written are a little easier, like B, 5 less than a number is 2. Let's do some equations. So 5 less than a number would be me subtracting by a 5. That is equal to 2. We'll get there. A number increased by 4 is -9. So a number is increased by 4. It happens to equal a 9. Ooh. Oh, -9, sorry. Thank you. -9. Here's a word equation. Here's an actual equation. How about I could say, following this pattern, 5 more than 2 times a number is 11. Right? Something like that. So 2 times a number increased by 5. Yeah, so again, that could create some ambiguity. Like for example, what do we call it? 2 times break a number increased by 5. Like, do you know where the bracket comes from? Again, it really depends.
What if it was 2?
So would that be incorrect? What's that?
Could you not write the x down and say like 2x increased by 5?
I think if something like that happened overall, generally, there might be a 0.5 communication mark because it leaves ambiguity. If you need to, if you feel like there is ambiguity, add more words to it. Yes.
Could you actually write down and say 2x increased by 5 equals 11?
No, that would still be mathematic, right? Like, so it's 2 times a number. So we could say, how about 2 times a number is increased by 5 to equal 11. But again, that's a lot of words. E, the product of 4 and a number is 28. So the product is a keyword that means multiplication. 4 and a number, the product is 28.
It's like and a number, not like addition.
So let's pretend, you're still having a little bit of, you're getting used to trying to write things efficiently. How about we just go left to right and do our best to be as non-ambiguous as possible? How about 3 is added by product of 2 and a number to equal 19. Would that work? Right?
Yeah.
2 is added by what? The product of 2 and a number.
But would that work if it was 3 is multiplied by a product of 2 and number to equal 19?
Multiply, then it's 3 times 2 times x.
No, would that put it in a bracket? Like would it?
Sure. Wording wise, it shows that the product of 2 and a number, whatever that is being done to something else,
Would
right?
it be correct to say 3 increased by 2 times the number?
Yeah, 3 is increased by 2 times the number. Yeah,
3 increased by 2 times.
I think so. 19. The quotient of a number and 5 is 20. Again, something like that would be the quotient keyword. A number is divided by 5 to equal 20. Quotient.
You write the other way like x with the division sign 5 and it's good x.
The x divided by 5. Yeah, I mean, this works too. It's the same meaning. A number squared and twice a number is 2. Whew. A number squared and twice a number is equal to 2. It wouldn't be a number and twice a number squared. Like that wouldn't be the case because it would be explained differently. Okay. So yeah, sometimes it can be ambiguous. The goal is, of course, you have to be clear. And again, I don't think some people, not everyone would have appreciated this exercise. It's sort of the point. You have to be very clear in what you read as well as what you communicate. That's why there's communication marks. Yes.
Why wouldn't it be x to the 2 times 2? That a number squared and twice a number. Because I was thinking like it would be like x.
The
twice.
word "and" does not represent product. Yeah. Of
But
represents
why
multiplication.
does twice a number equal x to the 2?
Hmm?
Why does twice a number equal x?
Twice a number is 2 times x. Well, what's twice 5?
Oh,
You know what I mean? So just the English of it. All right, let's move on. Another thing you might want to watch out for to be prepared for word questions is the idea of substitution. Substitution is a kind of technique where you replace, aka substitute. I don't mean to be sarcastic. Substitution is where you literally replace or substitute a variable with a number. For example, take a look here. Your first example says, here's your expression, 5x minus 7. Are you with me? Here we go. X equals -3. You will plug it in. So this expression equals 5 times x, but no, not x. 5 times 3 minus 7. Substitute. Replace. So 5 times -3 is -15 minus 7. The final answer is -22.
Wait, why is there a really big space? Wouldn't it be 5x minus 7x equals -3?
There is no x here.
Yeah, but what's the x all the way over there? Why is it?
Is
so
to
far
show
away?
that this is the value that I'm substituting. It is not part of the equation. Well, not part of the expression. So here's my expression. This is the w. what does that actually equal?
Oh, W actually equals, oh, okay, okay. So you're trying to figure out what the actual answer
So
would be.
-3 W plus 4. Again, I'm plugging in. So this expression would equal -8.
Oh, so you can actually-
Michael? That's it. That's it. Substitution. Let's keep going. Part C. Same thing here. If I give you the value of the variable, substitute it in, and tell me what this equals. Every time you see an X, I'd like you to plug in the number it represents. So turn the page. We're in the back of the first page. So this is -5 squared. This is -6 times -5, and you solve. I'll go through this a little bit quick. -5 squared would be +25. -6 times -5, +30. And we have +2. The final answer is 57.
Yay.
It's -25.
Times itself. So -25 times -25. And while we're waiting, the final test would be here. This time just for fun. Not like I'll ever give this to you really, but just for fun. Actually, maybe I would, I don't know. X equals 1. Y is -2. Z is +3. See if you can take all these and substitute accordingly. What does this expression equal if those three values are put in? Think of it as a puzzle. Why not give it a shot? And hopefully you entertained me a little bit, or you entertained my words a little bit and tried it. X is 1. So this entire thing that has been cubed, I plug in a 1. My Y value is multiplied by 3. So instead of a Y value multiplying by 3, a -2 is multiplying by 3. A -4 is multiplying with Z, but instead of Z, -4 is now multiplying with +3. We have 1 -6 -12. And solve to be -17. Question, Ellie?
Oh, no, I was just gonna say, can I go?
Okay, ask away. Now is a good time. What's up? Sure you're okay? It's a good time to ask questions because as we move on to bigger and better things, and we're preparing for things like grade 10 and whatnot, you will get a lot of situations, even in science class, actually, if you remember, in certain science classes, specifically electricity, I think in grade 9, you will have all these things called formulas. That's next class. That's the next example on the bottom. A formula is essentially, when we get there, something is equal to this big equation, and your job is to plug in numbers. Take a look. I'm going to clear this here. So before I actually get to this, were there any questions from A, B, C, or D you'd like to clarify? No? Okay, let's do it. Here it is. You recognize this formula for an area. Okay, well, area is length times width. The question gives you length as 5.3. The question gives you width as 2.1. That's centimeters. That's centimeters. And area equals length times width. Do you see what I mean by substitution? This is a generic formula. It was used everywhere. And I'm sure you've seen it in past classes. Whatever the question gives, you literally plug in and throw it into the calculator. So let's do it. If we were to use substitution, that's the correct term, area would be length, 5.3 centimeters, because I wrote it here, width, 2.1 centimeters, I wrote it there, so I'm substituting in. And that gives me something in my calculator, 11.13. Sounds about right. And that will be centimeters times centimeters. This is why the unit is centimeters squared. Centimeters multiplied by itself. So every time you have an area, you're always asked to write centimeters squared. You probably memorized it, but now that you're sort of seeing the substitution in action, I hope that you believe it. Same thing with this example. If you didn't know already, the formula for the area of a circle is pi r squared. Just out of curiosity, does anyone know? Okay, this I expect everyone. Does everyone know what pi is? Okay. Does anyone here know where pi comes from? Oh, Elliot, enlighten me. Yeah, you're right. But again, where does that number come from? Someone just pull it out of their butt? Something about a circle, yes. Yep.
Oh, well, the number.
No? Okay. Just think about it. It's really valuable. It actually applies itself to your ratios unit. Ooh. But anyways, do you know where it might have come from? Maddie, is that a hit? Well, it is related to the circumference. Absolutely. It's actually very important to the circumference. The idea is this. No matter what circle you draw, okay, like alien UFO, whatever. If you walk this distance around, in other words, if you walk the circumference, are you with me? And another person walks the diameter, the proportion between circumference and the diameter will always be pi. So whoever walks this circle will always walk more than 3 times the distance that this person walks, no matter what circle. And it happened every single time. Mathematicians of old were like mind-boggling. Why is it always this number? It's a magical number, so that they established as a magical number. And the applications of this became like crazy. Anyways, I'm wasting enough time. You will see this sort of talked about again and again and again, but just to impress your math teachers in like grade 10 and whatnot, keep an idea for it. Okay, radius, diameter is 10 centimeters. There is no room for diameter here, only radius. For those of you who don't know, diameter is the distance from edge to edge as it intersects the center of the circle. Radius is half of that. So that's radius here.
So wait, what? Radius is always half of the diameter?
Correct. By definition, the diameter is from edge to edge as you go through the center. Radius is half of that distance. So the diameter divided by 2, the radius is 5 centimeters. Now I have r, I can keyword substitute. I don't know what 25 times pi is, so I will calculate that for you. 25 times not 3.14, but I'm going to use the pi button in my calculator, giving me 78.53981633339. Mr. Kim, you're being way too extra. Okay, so 78.54 centimeters squared. Remember, 5 centimeters is what we used. So when we square it, it's already centimeter squared.
We have a circle question.
If I provide a formula, then it will be a formula question. It wouldn't be a circle question, right?
So we won't have any questions.
I could give you the formula for circumference, for example, the distance around a circle. And all I expect you to do is take my formula, plug in numbers, right? We're substituting here. Okay, I am going to see how long it will take for me to get through the next page. If people are struggling with it, I'll maybe end at the end of this page and maybe finish off the last page tomorrow. But it is my hope that we'll be able to get to the last page and leave the rest for homework. Okay, so bear with me. Any questions about substituting inside a formula? I'm sure some of you might still want some practice and you will get it. But for now, conceptually, I hope it's like, okay, I just got to try it. If I get it wrong, I get it wrong, but I'll at least know what to do to start. Here we go. It is. Disclaimer, everyone. Okay, this is the final little bit, and I really want everyone to pay attention. This page will really test whether you have been keeping up and understanding how to do the inverse of operations. Some people are still, oh, I see a 5, I'll just bring it to the other side and make it a negative. That's going to be a little bit more challenging once we get to this section, and you'll see why. A blank describes an algebraic relationship between 2 or more variables. That's what we just talked about. It is a formula. Some examples include area equals length times width, right? So e.g., another example would be volume of a 3D object, like length times width times height. I think you recognize these formulas, right? How many people in their grade 7 or grade 8 year worked a lot in geometry? Worked a lot of this algebra stuff in geometry. Okay. How many of those questions do you remember gave you the volume and asked you to figure out a dimension? One person sort of remembers that. Okay. Then I'm going to approach this like it's new to everyone. That's fine. Formula, so this is the part I was just talking about where you rearrange. Formulas can be rearranged to isolate different variables. For example, instead of volume equaling length times width times height, did you know that height could equal to volume divided by length, which is also divided by width? This is what I mean by rearranging. So let's take a look at an example I hope that everyone can relate to. No. Speed, which is in kilometers per hour, of a moving object is equal to the quotient distance in kilometers and time in hours. Do that one more time. Speed is equal to quotient of distance and time.
So like the distance and time would be on one end of like the equal sign. And
Yep, just writing it out. I'm literally going to read and turn it into math. Speed, which is S, is equal to quotient division of D and T. Yes, just like product is multiplication. Right? And that sort of makes sense. Take a look. I'm going to use units. Okay? Speed is kilometers per hour. Right? Distance is kilometers and time is hour. Left and right. Left equals right. It's That's why it's a formula. That's why we measure it in kilometers per hour. It sort of makes sense. Determine the speed of the object. So I'm looking for speed because that's what they're asking for. Distance is given as 400 kilometers. Time is given as 5 hours. Let's just do H for
Oh,
consistency.
so then you could do 400 divided over.
So knowing what the formula is, what you're doing is substitution. You know what D is, you know what T is, and D and T happen to be inside the same formula. So S is equal to, how about I do the full equation? D over T, which is the same as 400 kilometers over 5 hours. Which happens to be 80 kilometers per 1 hour, or just 80 kilometers per hour. Does that look familiar, everyone? From unit 2? It's called the unit rate. Lol.
What if the upper number, what if 400 didn't divide into 5?
Okay, gotta remember it. Pardon me?
Can you go over it again?
The A part? Sure. The question said speed.
Oh, wait, never mind, never mind.
Okay. So it's all coming together, right? So this is what I mean by how math continues to build on top of each other. We are building this stuff on the arithmetic that you might have learned when you were younger, like adding and subtracting and whatnot. Once you have this, you're ready for bigger things. You're ready for actual relationships and talk about it. Once you have straight line relationship, you can do curve relationship. Once you have curve relationship, we can do multiple wave relationships, so on and so forth. The world is huge out there, but we'll take baby steps. Yes, ma'am.
What if it was like, what if 400 divided by 5 was like 80 over 13? Like I'm not saying it is, obviously, just in another equation. What would you do if the end result wasn't a whole number?
Then give me it as a decimal over 1.
Oh.
Like, when would you ever say,
That's what I was
my
wondering.
speed is 100 over 3, like 100 kilometers every
Well, I
3
know,
hours?
I was just wondering, because like you said in the other unit, that it's like always better to do fractions.
Oh,
like,
correct. That's a good question. Mathematically speaking, I prefer 100 over 3. But when we are talking about word questions, what is more efficient or more useful for a human being? To give it as a decimal, for sure. Right? That makes sense. Thank you. Rearrange. So this is the part that's more complex. Rearrange the formula for distance, which means you're isolating for D. Here it is, everyone. Here's the challenge. And this will be particularly challenging for those who are just flipping the sign and bringing to the other side of the equal sign. I want highlighted D all alone. What is happening to D right now, mathematically? Think carefully, I'll give you like 15 seconds. Something is happening to D, and we are trying to get D all alone. Patrick, you with me? Okay. Make sense? Stephanie, you with me? Sort of? We'll just answer this question. Something, D and T, what is the operation or what is happening between D and T right now? Yeah, what's the inverse of division? I am going to multiply both sides by a T. Why? Again, the reasoning is I want D all alone. So this is from your fraction practice. If you do this, guess what? I isolated D, and on the other side of the equal sign is S times T.
Oh, do you have the dot in between? It's not just like
Oh,
ST.
it doesn't matter. ST is fine. It says explain each step when rearranging the equation. So that's my one step. I'll say something like, to get D all alone, must do the inverse of division. I'll do the capitals, division of T. Therefore, must multiply T to both sides of equal sign. That's my explanation. There it is. So the reason why we would do something like this is because question D says, what is distance? Speed is 6 kilometers per hour. Time is 1.5 hours. They're not asking for speed this time. This time speed is given. So this is why instead of using the original equation, we will rearrange it. Say that distance is equal to speed times time, 6 times 1.5, that equals 9. Yeah, I think this is a good time to stop. Any more than invite the first of the same. So just hold on for a second. The question told you that. Look at the question. The time. Look, I wrote it right under the question itself. Look, the speed is this. Time is that.
Oh.
Right? So that's where I'm pulling out the information and turning it into an equation.
Wait, so when you actually do that and you figure out what that D is, what is the like, what are you figuring out? Like what is 9 kilometers an hour? It's like,
what is the distance when this is this and that is
changed it. Sorry, I was blanking out for a minute. I thought it was the same question as before, and I'm like, what is?
Well, yeah, I mean, the goal of C was to revert. So quick recap from the beginning. Okay, from the first page. Changing words to equation and vice versa is going to be a very important part of this week. Next page. If we are to solve word problems carefully, we need to know how to substitute. We also need to know formulas. There you go. And then the last thing, if you are able to do both, the final step would be read a sentence and try to pull information from these English words to create an equation or a formula or something. And then you solve it using your skills for mastery. So it's all coming together this week. What I'm going to do is try to help you set up an equation for the very last example. And I'm going to challenge you to try to finish this back page before you leave today. So here's my little help. Look at the last example. And this is something that's very practical. Even I do it. And it's helped me quite often every time I had to go across the States and I was trying to make sense of the weather of the day. Let's say you went with your family you went to a coast-to-coast trip on a bus. And everything American is like, you know, it's 100 degrees out there. I'm like, oh my God, I'm gonna die because 100 degrees is really hot. But no, it's in Fahrenheit. It's a little different. The temperature in Fahrenheit can be converted to Celsius using this formula. Ready? See if you can make sense of it. Fahrenheit. So F is equal to 32 more than the product of 9 divided by 5 and this. Woo! I'm going to give you a minute to see if you can get the right equation out of this. Okay? Fahrenheit is equal to 32 more than the product of 9 divided by 5 and the temperature in Celsius.
Basically, we're doing on the first page, just in like more depth.
Next level. Maybe this will help. Yep. Oh, you're gonna give it a shot? Okay, go for it.
F equals 32.
Uh-huh. Uh-huh. There's got to be a C somewhere.
Oh.
Plus C. Anyone else? Not bad. Yep.
So I took it up. 32 more than the product of. So 32 plus 9 over 5 times C.
Okay. Anyone else? No one? Going once? Going twice? All right. The correct answer actually is going to be the right side. The reason why is this. It's tricky. I know some people would have focused on the and, right? Right? You focus on the and. Absolutely. But the confusing part, it's that I'm looking for the product of all of this. Give me 9 divided by 5. Give me the Celsius and take the product of it. I'll say it one more time. Give me the product of this number and that number. If I say it like that, it's probably clear. Give me the product of A and B.
I just did it because I knew that you had to add 32 and divide 9 by 5, but there's nothing else to multiply by C.
Oh, so you're just it.
Multiply by C.
This is very clear. Product of means multiplication. Well, multiplication of what? Of this number and that number. So Fahrenheit is, I need the product of 9 divided by 5 and C, but then 32 more than that. This is the formula that you would use to go from Celsius, from Celsius and turn it into Fahrenheit. Using this, you're going to have a challenge in part C where you're going to reverse the formula. I'd like you to try this as an in-class challenge. You only have like 15 minutes with me. Tomorrow we will finish this off and you'll get some more work questions to challenge you. All right, see if you can do it and I will stop everything.